Today we're going to look at the difference quotient and slope. I'm going to start the conversation talking about slope, and then we'll get to the difference quotient and how we're going to use that along with slope. All right, so first of all, what is slope? Well, slope is defined a couple of ways. One of my favorite ways is it's the change in our y value divided by the change in our x value. You've probably seen it like this: y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which again is just talking about how much the y is changing compared to how much the x is changing. All right, well, what if I wanted to find the slope from point A to point C? So we're talking about the slope or the average rate of change from point A to point C. So what I'm going to do is I'm going to find out how much the y value changes. Notice that from C to A, the y value changes from 8 to 0. So for our slope from A to C, we're going to get 8 minus 0 for the change in the y values. And notice that the x value goes from 4 to 0. So our change in the x value is 4 minus 0, which ends up being 8 over 4, which reduces to 2. Now, in a similar way, we can also find the slope from point A to point B. So the slope from A to B, again, is going to be that change in our y value. So the y value at B is 2, and the y value at A is 0. And the x value is also 2 minus 0. So I end up with 2 over 2, which reduces to 1. Now, another way to look at point A is to look at it as the function where x is equal to 0. So let me show you what that looks like. Remember that our function f of x was equal to 1/2 x squared for that parabola. So f of 0, what does that mean? Well, that means anywhere in my original function that I find in x, I'm going to replace with the 0. So 1/2 of 0 squared ends up being 0. So notice that we do get that point 0, 0, where the input is 0 and the output is 0. Now we can do a similar thing for point C, where I'm going to look at it as being the function at 4. So I'm going to replace all the x's in that original function with a 4, and then simplify. So I get 1/2 of 16, which ends up being 8. So again, my input was 4 and my output was 8, and notice how that corresponds with point C. So with that idea in mind, now we have another way to look at the slope between point A and point C. So remember that it is the change in y over the change in x. And in this case, how much does the y change? Well, we went from f of 4 to f of 0. And how much did the x value change? It went from 4 minus 0. Now notice if we wanted to go ahead and calculate with those numbers, what did f of 4 equal? Well, that was 8. What was f of 0? It was 0. And then 4 minus 0 is 4. So again, we end up with 8 over 4, or 2. And so you notice that that matches up exactly with the slope we got previously. Now, one more way to write this same slope function, f of 4, I could also write as f of our original function plus 4, or f of 0 plus 4, minus f of 0, and the change from those two functions was 4 on the x. Now here's what I want you to notice, is compare this with our difference quotient. That looks very similar, doesn't it? All right, so now we're going to look at how we're going to apply the difference quotient. And remember, I said the difference quotient was just a fancy way to write slope. So here are the steps that I'm going to use to help simplify this difference quotient. First thing I'm going to do is I'm going to find what f of x plus h is equal to. Once I get that, the next step is I'm going to take my original function, f of x, and I'm going to subtract that from f of x plus h. And I'm going to use something that I call the stacking method. And then the third step, I'm going to factor an h from out from the numerator, and then I'm going to divide that h by the h that's in our denominator. Or as I like to say, I'm going to get the h out of there. So, if you remember, our original function was f of x was equal to 1/2 x squared. So, first thing I want to do is find f of x plus h. Well, what does that mean? Well, anywhere in my original function that I have an x, I'm going to replace that with an x plus h. So now let's simplify that. So this x plus h quantity squared means that I have to FOIL that. There's two factors of x plus h. So it means this, x plus h times x plus h. Okay, so when I FOIL that, I end up getting x squared plus 2hx plus h squared. And then last, I can distribute that 1/2 to each of those terms. So I end up with 1/2 x squared plus hx plus 1/2 h squared. So I've taken care of that first step. I've found f of x plus h. So now the second step is I'm going to take my original function and I'm going to subtract it from f of x plus h. So my original function was negative 1/2 x squared. So I'm going to stack that so that it matches up with the like terms. Okay, when I subtract that, this term cancels out with that term, and I'm left with hx plus 1/2 h squared. So what have I just done? I've found the numerator of my difference quotient. So now I need to do step 3. So I need to factor out an h from our numerator and divide out the h that's in the denominator. So I need to get the h out of there. So here we go. So my numerator is hx plus, sorry, let me write that correctly, plus 1/2 h squared. And our denominator is h. So I'm going to factor out an h from our numerator. That'll leave me with an x plus a 1/2 h. And then we have our h in the denominator. Notice that this h cancels out with that h. So what is the final result? We end up with x plus 1/2 times h. Great work. Good job. We figured it out. So what? Who cares? What's the point? Why did we do all that? Okay, remember, I said that difference quotient is just a fancy way of writing slope. So what did we really figure out? We figured out the slope of that parabola. Okay, well, let's see if we can utilize that slope. So I want to find the slope between point A and point C. Now remember, we already calculated that previously, and we found that that ended up being 2. But let's use this little equation that we have now and see if we can get the same result. So if I'm looking at our starting point, x in that case ends up being 0. So I'm going to put a 0 in for x. And how much did our equation change? Or I mean, how much did our function change from point A to point C? Well, it looks like we went over 4 spaces, didn't we? So that's going to be my h. I'm going to put that in as 4. So I end up with 0 plus 4/2, which ends up equaling 0 plus 2, or 2, which shouldn't be a surprise because we had already figured that out before. Well, let's see if we can find the slope between point A and point A and point B. So the slope between A and B, Okay, again, our starting point for A, the x value is 0. And how far did we go over? Well, from here to here is 2 spaces, so I'm going to put a 2 in for our h. Okay, when we calculate that, we end up with 0 plus 2 over 2, which ends up being 1. And again, not a surprise. We'd already calculated that. All right, well, what about the slope between point B and point C? Okay, well, what's our starting point at point B? Well, the x value is 2. And how far did we go from point B to point C? Well, that was a difference of 2. So we're going to put that in for h. We moved over 2. So we end up with 2 plus 2 over 2, which ends up equaling 3. So the slope from point B up here to point C is 3. Okay, so I just added a new point, point D, which happens when x is equal to 1. What if I wanted to find the slope from point D to point B? All right, so what is our x value at point D? Well, it ends up being 1. And how far do we have to move over from point D to point B? Well, we're just moving over 1 space, so I'm going to put a 1 in for h. So we end up getting 1 plus 1/2, or that ends up equaling 3/2, or 1.5, however you want to write it. So the slope between those 2 points is 1.5. Now, one last problem. What if I wanted to find the slope from point D to point D? In other words, I'm not finding the average slope from 2 points. I'm finding the slope at exactly point D, an instantaneous slope. Okay, well, what's my starting point? Well, the x value is 1. And then how much did I change when I went from point D to point D? Well, I didn't change any. So I'm going to plug a 0 in for the h. Okay, so now when I calculate the slope, I end up with 1 plus 0 times 1/2. So I end up just getting a slope of 1. So that's kind of the cool part about using this difference quotient, is if I wanted to find the slope at just one location, that change in y over the change in x, what I'd end up finding is that the change in x would be 0. And we know that we can't divide by 0. So that makes it really complicated and impossible to do if I'm trying to use this type of slope formula to find the slope at just one point. So this quotient formula allows us to find the slope at any individual point along our graph without having that problem of dividing by 0. Now let's try another example. We'll make this one just a little bit more complicated. So I have the function f of x equals x squared plus 2x minus 1. And I want to find the difference quotient with that function. So my first step is I need to find what f of x plus h is equal to. So f of x plus h means I substitute an x plus h anywhere I find an x in my original function. Now from here, I'm going to simplify as much as I can. So I'm going to FOIL those two terms, and I end up with an x squared plus 2hx plus h squared. And then I'm going to distribute that 2 to both those terms. So I get a plus 2x plus 2h, and then I have that negative 1. So that takes care of the first step. Now what I'm going to do is I am going to subtract our original function from the f of x plus h. And remember, I'm going to use that stacking method. So I'm going to take the x squared and put it underneath the x squares. I'm going to put the 2x and put it below the 2x, and I'm going to put the negative 1 below the negative 1. And then remember, I'm going to subtract these. So when I subtract x squared minus an x squared, that cancels out and I get a 0. And when I take the 2x and subtract off the 2x, those also cancel out and I get a 0. And then the same thing here, the negative 1 minus a negative 1, those cancel out and I get a 0. So what am I left with? I'm left with the 2hx plus h squared plus 2h. So that takes care of step 2. Now I'm going to put this in the numerator, so 2hx plus h squared plus 2h, and I'm going to divide that by h. So I can factor an h out of that numerator. So I'm left with that's not right. I'm left with 2x plus h plus 2, all divided by h. And then those h's cancel out, and the final result is 2x plus h plus 2. So, what did I find? Well, I found the slope of this function here. And so if I want to find the slope at any point along that parabola, I can just plug in the x value and put a 0 in for h, and I can find the slope anywhere along that parabola.